So theorem number 1 says, we're about to write an equation for an ellipse with a center at 0, 0. And the major axis is along the x-axis. So what that means is, let's plot the center, which is at 0, 0. Okay. Major axis along the x-axis, what that means is longer on the horizontal axis. So I'm just going to randomly plot a dot somewhere. It doesn't have to be exact, okay? As long as it's more like that. So that's your major axis. You have 2 vertices. Vertex 1 over here. Vertex 2 over here. Those are vertices. You have 2 foci as well. Okay. This is focus 1. This is focus 2. And no, these are totally not drawn to scale. Now your triangle, the triangle that you need to know to find your A, B, and C. From the center to one of the foci, what variable is that? That is always, always C. Okay. From the center to the minor is what variable? B. So as our low tech just proved, the focus here to this minor is distance called A. So that's why we use A square equal to B square plus C square. Okay. So based on that drawing, is it possible for us to find the foci? What would the foci be if the center is at 0, 0? How would we label the foci? 2 C's? C comma 0. Would you agree that I can do the negative and positive C comma 0 because the center is at the origin? How about the vertices? How would we find those? A, you're right. Okay, remember, the distance from the center to the vertex is an A distance. It's not drawn to scale, so it may not look like it. But when we did the low tech from the center, didn't I fold that in half? Right? So that's A. So that's going to be plus or minus A comma 0. So the formula goes x squared over something plus y squared over something equals to 1. It always equals to 1. Okay? Now because your major axis is along the x-axis or is horizontal, the x squared will get the longer length out of the a squared and the b squared. So this is going to get an a squared here, and this will get the b squared here. That's your minor. B squared is shorter than a squared. So that's why the minor is vertical, where A must always be bigger than B, and both of them have to be positive because they're distances. If you don't like writing A squared equals B squared plus C squared, oftentimes we're asked to find B squared. So you can write B squared equals A squared minus C squared, or vice versa. Okay? Any question on that theorem? Flip over to our next theorem. Similarly to the next one, this one says your major axis is along the y. So it's vertical is normally what I call it. The center is still at 0, 0, it says. Along the y-axis, I'm just going to make that much longer. Okay. Again, we have these as vertex 1 and vertex 2. Those are called vertices. Vertices are always on your major axis. Your focus 1 would be somewhere up here, not drawn to scale, so F1, F2. The distance from center to F1, it's always C. Does not matter how it is positioned. The distance from the center to the minor is always B. That means the distance from the focus 1 or focus 2, doesn't matter, to the minor is A. That's always A. Okay? And again, similarly, from the center to one of the vertices, it's also A. Okay, so based on that drawing, is it possible for us to find the foci? What would you write for our foci? What is it? 0 plus or minus C. Okay. How about vertices? 0 plus or minus A. Now, our equation is x squared over something plus y squared over something equals to 1. Which one's longer? What position is that? Vertically or horizontally? Vertically, right? The major axis is vertical. That means the y squared will get the longer value. Which one do you think is the longer value? A squared or B squared? A squared. So in this case, your y will get A squared. That means x will get B squared. Okay? And similarly to earlier, A must always be bigger than B, and they both have to be positive. And Pythagorean theorem said C squared plus B squared equals A squared in the ellipses. So that's if the center is at 0, 0, which is so much nicer. What if it's not at 0, 0? H and K, yes, it is. So let's, for the sake of simplicity, we'll put the center right here in quad 1. We'll make this, do you guys want to do vertical first or horizontal first? Okay, so let's do major here and here. Not drawn to scale, okay? Vertex 1, vertex 2, your minor up and below. Okay, so here's not a very pretty ellipse, but we will stick your foci, focus 1 in here, and focus 2 in here. This distance is going to be called C. This distance will be called B. And this is always A, the hypotenuse. All right. Center. It will always be H comma K. Does not matter how it is positioned. Your equation is no longer just x squared. Your equation is quantity x minus, guess what? H quantity squared over something plus y minus k quantity squared over something always equal to 1. Now, which one gets the a squared? X, you're right. That means you're left with b squared over here. Okay. Now, remember, this is for us. The reason we're doing this is that we have one location to find your information. Try not to memorize this stuff. Try to have a visualize it. All right, let's find the vertices. If this is the center, somewhere at h comma k, how do we get v1 and v2? Is h changing or k changing? H is changing. Changed by how much? An a value, isn't it? So you either add a or subtract a. So h is either plus or minus a comma k. Foci, similarly, foci is changing by how much? A, B, or C? C. So plus or minus C comma k. Major axis is parallel to which axis? The x-axis or the y-axis? x-axis, parallel to x-axis. Okay. So that's that portion. So the bottom one will draw your center here. We'll draw your vertices somewhere here. So vertex 1, vertex 2. No, they don't have to be pretty or perfect. Just looks more like an ellipse. So foci, here's focus 1, focus 2. And just like prior, we are going to say that this is a C distance, this is a B distance, this is the right triangle, and that's an A distance. All right, center is back to H comma. Okay. All right, x minus h quantity square over something plus y minus quantity, y minus k quantity square over something equal to 1. Okay, always equal to 1. Where do you think the a square is going to go?
1.
Yep. That means you're left with b squared here. Vertices. What should we write down for vertices? H comma k plus or minus a. Good, because you're changing an a distance. And then foci, similarly, h comma. Now, your major axis is parallel to the y-axis. Okay. To get a, b, and c, is it a squared plus b squared equals c squared?
No.
No, be very cautious. Let's write down one more time. What is it? C squared plus b squared equals a squared. You're right. All right, let's do example 1, 2. 1a, 1b, 1c. If we can get 1a, b, c, and done, we're good. Find the center, vertices, foci of the ellipse, and graph it by hand. What's the center? Yeah, we love it. Center, 0, 0. Check. Let's plot it right away. I'm going to make some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Do we know, even before graphing it out, the position of this ellipse? Is it horizontal? Is it vertical? Vertical. How do you know? B can never be bigger than A.
Is the A the major y squared, which tells you that the major axis is parallel to the y?
Yes. Can you guys see that this is bigger than this? By the way, what's under the x squared?
1.
Yeah. So A squared, class, is actually 16. B squared is 1. A squared is always bigger than B squared. And A squared happens to be under the y. So Emma's right. It is going to be vertical. Is it possible to know what A is right away?
Yes.
What is it?
4.
Yep. What's B?
1.
Perfect. What do we use A for?
The distance between the set.
To, yeah, so we can straight up graph it, right? We have the major, V1, V2. Do we have the minor?
Not yet. Oh, wait, yeah.
Yeah. From the center, we go how much? 1 left and 1 right. Immediately, don't I have enough to graph? Okay. Graph by hand check. Now we just need to locate the vertices. What are the vertices?
0, 4, 0, negative.
Okay. 0, comma, plus or minus 4. Checked on the vertices. We need to find the last piece, which is foci. How? What is it? Formula is c squared plus b squared equals A square. C square is unknown. B square is 1. A square is 16. That means C square is 15. Yes or no? C is rad 15. Okay. No, I don't need you to put in decimal. You just know. Yeah. We're going to do plus or minus rad 15. Now, if I ask you to plot it, between what two integers would that be? What two integers would that be? Yeah, 3 and 4. Somewhere between 3 and 4. I'm happy. So focus 1 and focus 2. And so we answered all the parts that they wanted us to answer. Center, vertices, foci, and graph by hand. All right. Example B. What would you do? Factor. Would you agree? Complete the square. Remember, in the ellipse equation, what must it equals to? 1. Currently, is it equaling to 1? No, so you must do what? That's right. Every single term must be divided by 40. Okay. So now we get to 1 equals. Now, what's on the other side? Y squared over 8 plus x squared over 5. Good. All right, let's answer the question. Center is where? 0, 0. All right, let's plot 0, 0 right away. We're going to make some tick marks. 1, 2, 3, 4. Okay. Before we graph this out, do we know the position? Vertical or horizontal? Vertical again, right? Because can you guys see the y square is over 8 and 8 is much bigger than 5? So what's a square? 8. Okay, that means a is rad 8, which reduces to 2 rad? 2 rad 2, right? Okay. Now, I don't need a perfect decimal. How would you plot 8? Rad 8, I'm sorry. Rad 8 is in between what two integers? 2 and 3. Would that be okay? It's like rad 9 is 3, so I'm going to put it slightly closer to 3 if that's okay with you. So V1 and V2. I'm going to answer the question. Oh, we already have the center. Vertices. How should we write the vertices coordinates?
0 plus or minus
2 rad 2. Perfect. Do we know the minor? What's b squared? 5. Good. What's b?
rad 5.
Rad 5 is in between what two integers? 2 and 3. Okay. Probably a little bit closer to 2. Okay. Do I have enough to graph my ellipse? Yeah. Almost like a circle. Okay, we need one last thing before we finish with this one. What are we missing? Yep, foci. I need to find c, don't I? C squared equals a squared minus b squared. Would you agree with that statement? What's a squared? 8. What's b squared? 5. So c is 3. I mean, c squared is 3. That means c is rad 3. So foci 0, comma, plus or minus rad 3. If I ask you to plot it, where should we go? Between 1 and 2 sounds great. Okay. Focus 1, focus 2. So far, easy or difficult? Yeah, I love ellipses. All right. C. What would you do on C? Complete the square. You're right. Okay. Before you complete the square, what should you do?
squared and x's together.
Yep.
Y squared.
Perfect. Well said. Okay, complete the square. Make sure you bring all the x's together, all the y's together. All right. Tell me what to do next. Mm-hmm.
You divide the middle values by 2. Way to get the factor.
Yes,
Factor.
you're right. So take out 4. X squared plus 2x plus blank. Take out a 3. Y squared minus 2y plus a blank. All good? Yes, go for it. Equals 5. All right, first blank. What do you want to fill in?
1.
1. So what you added to the left, we will add to the right. Would you agree that 1 is really being multiplied by 4?
Yeah.
Yep. Second blank. Also 1. But that 1 also get multiplied by a 3. Okay. So we are going to factor x plus 1 quantity square 3 times y minus 1 quantity square equals what's on the right side?
12.
12. Beautiful. What would you do next? Yes, divide each and every term by 12. Remember, must equals 1. So now we have x plus 1 quantity square over 3. Good. And then y minus 1 quantity square over equals to 1. Position, do we know where? More vertical, more horizontal? Yep. Center. Is it at 0, 0?
No.
No, not this time. Where's the center? -1, comma 1. Perfect. Well said. I'm going to plot it, which I need to make tick marks. Okay, so -1, up 1. Got my center. What else do I need? Can I find a value? What's a squared?
4.
4. That means a is 2. Do I go up, down, left, or right? Up, you're right. Up 2, down 2. This is vertex 1 and vertex 2. I can also answer that question, right? Vertices. What's the first order pair for the vertex 1? -1, 3, and then -1, comma. Negative. Oh, I went down too much, huh? It's supposed to be just went down. There you go. -1. Would I be okay? Vertice 2, vertex 2. Okay, we got our vertices. Is it possible to find a b value?
Yes.
What's b squared?
3.
Yep. So b would be rad 3 in between what two integers again? So I'm just going to add a rad 3 to the right of the center and subtract rad 3 to the left of the center. Would you guys agree with that statement? And you said the distance is in between 1 and 2 distance, okay? So somewhere in between there. Again, I don't need a perfect decimal because you don't have a calculator that says graph by hand. So as long as you have a distance from the center in between 1 and 2 integers, I'm fine. I'm missing one more. Last piece of information. What's missing? Foci. What do we need? C squared. All right, C squared equals A squared minus B squared. So C squared, what's A squared?
4.
4. What's B squared? 3. Ooh, I like this. C squared is 1. That means C is
1.
Beautiful. So that means I'm going to go up exactly 1 and down exactly 1. So F1 and F2. So how do we label those two order pairs? 1 comma what? I'm sorry, -1 comma what? 2, good. And -1 comma? Perfect. That concludes our notes for today.